Hi, Mr. Burke. Well, this is my screencast for my spring maths program. Starting with my acknowledgements, I read some sections of the book for some review on background physics info and for some help with structuring my while loop. I also asked Catherine for constants because I forgot them, and I later on asked her to help me verbalize my objectives. I didn't feel like I quite knew what I was doing, so she helped me refocus, and she also helped me work on the skills of commenting and isolating. So, commenting out a possibly problematic section and then seeing if the problem was in the comment or if it was outside of the comment. She helped me practice those kind of strategies. And yeah, some other stuff too, but you can read, so I'll get to that later. So at first I started out and I felt like I had no idea what I was doing. So what I did was I first organized my steps in defining my constants, defining my objects and my variables, telling myself that I needed to iterate motion, etc., etc. And my constants, as you can see, are LO and K. And LO is the relaxed length of the spring, and K is a spring constant. Next, I defined my objects, my variables. So I created a sphere and called it ball, and made its position vector thus and its radius thus. Yes, one interesting thing was that at first I didn't quite know where to put the ball. But then I was like, wait, it's just gonna be the relaxed length of the string, but in the negative y direction. So that took me about 30 seconds to really think through. I created a box and named it board. And since it's stationary, it's just at the origin, and its size is thus. And then finally, this came much, much later, I actually created a helix and named it my spring. This part came much, much after the rest of these other two, because at first I didn't quite know how to format it. As I emailed you earlier, I was confused about how to, like, the syntax around a helix, and originally I had values and vectors in here for position and size, and then I wasn't sure of how to make the spring follow the ball, and then eventually, with some of your help, I realized that I just needed to establish that the position followed and the size followed certain values, certain variables. Okay. After I created my objects, I established my variables as well as the initial values of some things I'd be using later. So one thing which is going to stay the same, but which is a characteristic of the ball, is the ball's mass, I also commented some of the units, because otherwise I knew I'd forget and it'd kind of mess with me. So the ball's mass is characteristic of the ball's radius is unchanging, also an unchanging characteristic of the ball's starting momentum does change as I update momentum later, but its initial value is the vector is vector 0, or 0. So the board also starts with a starting momentum of 0, but its momentum doesn't change, so it just stays 0. And I also established and introduced the variable of gravity, which stays the same the entire time, which is why I grouped it with these other characteristics. Then I established my t and my delta t, and actually at first the interesting thing was I was having trouble with my delta t and my rate because my spring was going up and down like this. So I emailed you, and you helped me realize that if I could actually slow down the time to real time, it would move a lot slower. So what you said, I think, was that the delta t needed to be the inverse of the rate. And anyway, I found that that actually worked really well for me. So it went from my spring went from this to something a lot more manageable, which was great. This is a remnant of something I've been trying to work on before when I was really stuck and I looked at your trinket, but I commented that out. Actually, I can probably just delete it, as that is not essential. As I said before, when I felt I was really lost, I broke my process down into a couple of definite steps. So this is my note to myself, telling myself I need to iterate motion, and then to keep in mind what the total F net was, and the formula for F spring, And then here's my update loop. While t is less than 1000, that's just my while statement. I could also do while true, but I decided to go for a limited value. My rate means 100 times a second, so together this means that the computer will make the calculation 100 times a second. So together this means that the computer can only do 100, only go 1 second, 1 t per actual second, so it moves as if in real time, which made it slow down a lot, which was pretty helpful. Okay. Anyway, back to the programming. First I had to find fspring and fnet, and I established this by saying L was the ball's position minus the board position, L being the length of the spring, and then stretch was simply magnitude of L minus the relaxed length of the spring. And I found L hat through the definition of a vector, which is its magnitude times its unit vector. And then finally I put all of these pieces together to create fspring, which is negative k times s times L hat. And after fspring, I realized before that fnet was equal to, that fspring and fgravity were the only two forces acting on the system, thus it was fspring plus fgravity that was equal to fnet. So here in my fnet statement, I just said fnet was equal to the vector of 0, fgrav, 0 plus fspring, and this actually is interesting because previously I've been a bit confused about how to format my fgravity, and I would just establish fgravity as mass times gravity, which would be a scalar, and then I'd try adding it to a vector. I'd try making it a vector, but I would multiply mass by everything in the vector, and I just made a really confusing mess, and I actually kind of screwed that up in the quiz. So here I just decided to establish fgravity earlier as the value, and then just simply put it as the y value in a vector. Anyway, then I moved on to my momentum update. My momentum update line, the ball's momentum is assigned to the ball's previous momentum plus fnet times delta t. So pi plus the impulse. My position update is also here. The ball's position is assigned, the variable ball's position is assigned to the ball's previous position plus v average times delta t, and this v average, I found this v average approximate through finding the v final, which works because this isn't changing net force and it's a very small interval, so that's why I did pf over m instead of the arithmetic average of v. And then finally here's my spring axes update. At first I didn't quite know how to do this, and I had a whole long thing about how to update the size of the spring, and I had a lot of vectors. But then I emailed you and you helped me realize that all I really needed to do was make sure that the axes followed the ball. And then at the very ending, of course, I said that t was assigned to the previous t plus the change in t. Anyway, and then this repeats, obviously. So yes, this is my program. This is my spring. It's quite lovely. And yeah, this is the end of my this is the end of my screencast. Sorry about that. But as you can see, the ball bounces up and down. The spring follows it, so I consider this a success personally, considering I started out with very limited knowledge. But yeah, thank you for listening. Have a good evening.